Well, thank you very much for having me. So I'm here to talk about space, which doesn't really fit necessarily with the rest of the topics of the speakers. You might think, what's space got to do with healthcare? Well, the answer is actually quite a lot. There's quite a long tradition of the space sector and the healthcare sector working together. I mean, after all, think about the telescope. It is a piece of repurposed healthcare technology. Two lenses at the end of a tube. About 400 years ago, a Dutch spectacle maker took those lenses, repurposed them, put them together in a different way, and came up with something that allowed us to see the universe in a completely new way. So telescope is healthcare. And one of the first things that we wanted to look at with our telescopes when we invented them was a very rare event called the transit of Venus. Twice a century, thereabouts, Venus is seen to pass between us and the sun. And it's a really important event because with the Earth, Venus, and the sun all in one line, if you make careful measurements of that event from two places on Earth, you can use trigonometry to work out how far the Earth is from the sun. And then by proxy, work out how far the stars are away from us as well. So this event, twice a century, in the 18th century, we dispatched teams all over the world to try and observe this event, including the Royal Society in London, where I'm from, sent Captain James Cook on the HMS Endeavour down to Tahiti to observe the transit of Venus. He took with him sealed orders from the Admiralty that told him to explore and look for Australia afterwards. But his main goal going down there was to observe the transit of Venus. That's how important it was. And he did, made some very important measurements. But what's actually more remarkable is that him and his entire crew made it to Tahiti complete. Not a single person died. And that was revolutionary, because at the time, scurvy was such a problem for navigating at sea. And so thanks to the early healthcare scientists trying to work out what caused scurvy, Cook's crew managed to make it there in its entirety and make this incredibly important astronomical measurement. So without healthcare science, we wouldn't know how far Earth is from the sun. In more modern times, we've got our new view of Venus. Normally we can't see it because it's enshrouded by a really thick cloud of carbon dioxide. So our view of the surface is blocked. But one way to see the surface is to look via radar down through the clouds. And so you can see here the Magellan space probe being launched from the space shuttle in 1989. The very first time we'd launched something interplanetary from a space shuttle, sent it to Venus to make these wonderful maps of the Venusian surface. Now, to get something into space like that, well, that required a huge amount of power. Getting away from the Earth's gravity, you have to travel 11 kilometers per second to get into space. And you can see how much energy and fuel that requires. The liquid oxygen in the fuel tanks of the space shuttle. Now, the guy here on the left-hand side, David Saucier, he was an engineer with NASA and an expert in the fuel pump technology of the space shuttle. But he wouldn't have made it to 1989 unless he'd had a heart transplant. Because in 1983, he'd had a heart attack, and he sat on the heart transplant list for years until he finally found a donor. And there's his doctor on the right-hand side, Michael DeBakey. Once his surgery had been performed, the two men started talking. And they realized that actually, they kind of do the same thing. Saucier was an expert in the fuel pump for the space shuttle, but the heart's just a pump too. And so they worked together tirelessly for years to miniaturize the fuel pump technology from the space shuttle into a ventricular assist pump, which you can see there, just 5 centimeters across, implanted into humans to keep the heart beating for longer while you wait for your transplant. It's so small and lightweight that it could even be implanted into children. Saucier eventually died in 1996, so his life extended by 13 years because of his transplant. That same year, rights were granted to a spin-out company to produce these, and they were implanted in over 100 patients. So that's space technology being changed and adapted into something we can use in the healthcare sector. And that story is not a one-off. You may remember a couple of years ago, the European Space Agency made a particularly daring and famous attempt to land on a comet. The big question we wanted to answer was, how did life on Earth begin? What makes our planet a living one? And one of the big answers is that we have lots of water. But where did that water come from? One idea is that it came from comets, kind of ice mountains in space. And the early Earth would have been battered by these comets and delivered to us the water. So I wanted to land on the comet to see whether the water there matched the water here. Turns out it doesn't quite. So maybe the water that we have on the Earth didn't come from comets in the first place. Maybe it came from asteroids instead. But it was a 500 million kilometer journey taking more than a decade. The Rosetta spacecraft dropped the Philae lander, about the size of a washing machine, down onto the surface of the comet. Now you're going to see here this animation, it's a very smooth landing. That's not how it happened. The surface of the comet was a lot harder than we'd expected. The things to anchor it to the comet didn't fire properly, and so it bounced. It bounced several times and ended up on its side in the shadow of a cliff and couldn't charge its batteries properly with the sunlight. Until the comet then got closer to the sun. The sun's heat melted some of the ice, bathed the solar panels in light, and it woke up. So we have lots and lots of data from the Philae lander to tell us what this comet is like. What's that got to do with health? Well, here's one of the instruments on board Rosetta, the mothership of the lander. It's called Midas, and it's a dust experiment. One of the ways to work out whether the water on the comet is the same as ours is to take the dust grains as they come off the tail of the comet and analyze them. So they pass through this machine, and inside there's a needle that runs over the shape of the dust grain and maps out its shape. Now, normally on Earth, this kind of technology would take up a bench, maybe a room. This is the size of a shoebox. And that's the thing about space technology. It costs between 10,000 and 20,000 euros a kilogram to launch something into space. You cannot afford to make it big and bulky and heavy. It has to be small, it has to be light. So you're constantly miniaturizing technology, fitting what would normally take a lot of room into a very small amount of space. Not only that, it has to last for 10 years and work 10 years later when it arrives at the comet over that distance of 500 million kilometers. So it has to be light, has to be durable, and it has to work. There are no do-overs. One chance. And that makes space technology attractive to many other sectors. And so the company behind this device, Cedrat Technologies, took the needle and the actuator and have been trying to make it work again in heart surgery. The idea being that you press down on a particular part of the heart, stopping it beating locally, but you don't have to stop the entire organ, making heart surgery a lot less dangerous. It's already been trialed on pigs, and it's worked pretty well, and so they're hoping for good things in the future. So that's looking into space with telescopes and sending machines into space to learn about where we came from. We also send humans into space. Now, back in the UK, we've recently celebrated the return of our first astronaut to the International Space Station, Tim Peake, and here he is unloading a very valuable payload on the International Space Station. I'll just let you watch. So they are doing serious things up there, about 400 kilometers above our heads. But you can see that along with the gorilla, there's lots of other stuff strapped to the inside of the space station. They're doing lots of experiments, both for many different fields, including medicine. One of the key things is we're learning about bone density. In microgravity, our bones waste away quite dramatically. And so by correcting for that, making the astronauts do things to keep their bone strength up, we're learning about things like osteoporosis here on the Earth. Also, in vitro diagnostics. There's a lot of experiments going on up there about that kind of thing, miniaturizing technology to create devices for us in the future. But this is my favorite example. So on the left-hand side, you're seeing a field of galaxies in space, taken through a big telescope. On the right-hand side, some tumor cells down a microscope. Now, they're not that dissimilar. Now, when a team had this big open day at the University of Cambridge, they got lots of different departments together to talk, who wouldn't normally talk. And when they did that, the astronomers and the oncologists realized they were basically doing the same thing. Except astronomers don't count galaxies by eye. We haven't done for a long time. We have software to do that for us. So when the astronomers shared with the oncologists their software, suddenly we could automatically count changes in tumor cells down a microscope. We could do it as quickly as a doctor, we could do it as accurately as a doctor and more quickly. And if we keep developing the technology, we'll be able to do it quicker and more accurately than a human. So these examples, if you want to get involved in sharing, and I should say it's not just one way. I'm not trying to say that the space sector is your savior. There are so many examples of things going the other way, where we've really benefited from your expertise and your software. The European Space Agency have a network of business incubation centers, or BICs, throughout Europe, spinning out space technology to startups, turning space scientists into entrepreneurs and sharing their devices. There is a BIC in Sweden. There's a broker here in Finland as well. So talk to these guys. Find out what it is they've got. Because this is what it comes down to for me. I speak to something about innovation. Innovation is not creating the same thing twice. If we've done it, you don't need to do it. If you've done it, we don't need to do it. So let's talk. Let's keep talking. Let's find out what it is that you need. You find out from us what we need, and share as much as possible. And so let's continue the conversation. Come and talk to me. Send me an email. Send me a tweet. If any of you are already using space technology in your work, I really want to know about it. But yeah, space sector, health sector, they're not completely different. There's more in common than you think. And these are just some examples of the wonderful things we can achieve when we work together with someone we wouldn't normally talk to. Thank you.